Okay, let's take a look at your homework from last night. So you should already have that out. I should have already checked for completion, but let's talk through these answers. So when we look at this particular section, hold on one second, my workspace is opening up. What we're looking at are the different polynomial functions. We're checking out their degree so that we can know about the end behavior when we put the degree with the leading coefficient. We are also looking at the root behavior. So if we look at this one, number one, if we check out the degree, this is understood 1, 2, 1. So this one has a degree of 4. Because it's even, we know the ends do the same thing. And because it's positive, a positive times a positive times a positive, we know we have a positive leading coefficient and a degree of 4. So the ends both rise. So that gives us either D or B. Those two have ends that go up. Okay, now this should pass at 0. This one passes at 0. It should bounce at 3. It bounces at 3. And it should pass at -4. So that's why this one is D. Okay, let's take a look at number 2. If we look at the degree of this function, the degree is 5, and it has a negative leading coefficient. So we know it's going to rise to the left and fall to the right. Well, there's only one that does that, but let's check out the root behavior while we're there. If we look at this, does it bounce at 0? Yes, it's tangent at 0. Does it pass at 3? It certainly does. And is it tangent, or if we look at the graph, does it appear to bounce at -4? It does. So number 2 is C. Number 3 is B. Once again, we have a 4th degree with a positive leading coefficient, and that was our only other one that rose. But if we look at it, it's going to pass at 0, pass at -3, and bounce at -4. So bounced at -4, passed at -3, passed at 0. This one's B. And so that just leaves A for number 4. This one has a degree of 6 and a negative leading coefficient, so we know the ends are going to fall, and it bounces. It is tangent at -3, at 0, and at +4, and that gives us the 4 there. Okay, let's take a look at the next bit. All right, so we do the same thing on these when we're working through them. So let's talk through these answers now. If we look at this one, it has a degree of 5 and a negative leading coefficient. So we know it's going to rise to the left and fall to the right. We have x-intercepts at 0 and at 5. So that's where we start, 0 and 5. At the 0, it's raised to an odd power greater than 1. So not only is it going to pass through this point, but it's going to pass through with the inflection. Remember, the concavity of the graph changes at that inflection point. And then it's going to bounce here at 5. Number 6, the degree of this function is 6, and it has a positive leading coefficient, so our end behavior is rise. We graph our two x-intercepts. We have one at 1 and another one at 3. 1 and -3. It's going to rise to the left and rise to the right, and because they're both raised to even powers, it bounces at both of them. Now, number 7 was not in factored form, but you can factor this. Okay? This is a perfect square trinomial, which we can write as the binomial squared. And if we break it down, this is what we have. We have 2 of the x plus 2's and 2 of the x minus 2's. So this is how we would write it. So we'll plot an x-intercept at -2, an x-intercept at +2. We know it's 4th degree from here. We also know it's 4th degree from here because 2 plus 2 is 4. It's positive leading coefficient, so it's going to rise. And because both of these are to even powers, these factors are to even powers, it's tangent at both the x-intercepts. Okay, and let's take a look at what's left. The last one. Here they just gave us an idea about a function, and we had to come up with our own function. So when we look at this, it gives us end behavior. So we know as x approaches negative infinity, y approaches positive infinity. It's rising to the left. And as x approaches positive infinity, y does too. So it's rising to the right. That tells us not only is it an even degree function, but the leading coefficient must be positive. Then the graph is tangent at its x-intercepts. So it's tangent at -5. So our factor would be x plus 5, because remember, if this is the x-intercept, we had to plug this number in to get 0. So this number here is always the opposite of the x-intercept if there's no coefficient. So we have an x-intercept at -5, the x-intercept at 2, and tangent means it has to bounce. This power must be even. It can be any even power, but it must be even. Now, for mine, what is the y-intercept of the graph? The easiest way to find the y-intercept is to plug in 0 for x. So the x goes away. Plug in 0 for x. The x goes away. 5 squared is 25. -2 squared is 4. 25 times 4 gives me the y-intercept of 0, 100. Okay, and that covers the homework. If you have any questions about any of these, please ask me in class. All right, we're going to go back through some of the concepts from yesterday in today's notes. So if you did not pick up the notes on the way in the door, hit pause right now and go to the bookshelf as you entered the room, the bookshelf, and look for the notes for today. And then when you come back, press play. All right, today we are summarizing what we learned yesterday. We're talking once again about end behavior, and we have more examples. So recall that end behavior is determined by two things. Is it an even or odd degree function? And do we have a positive or negative leading coefficient? If it's even and a positive coefficient, both ends rise. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y also approaches positive infinity. Both ends rise. If it's even degree function, but we have a negative leading coefficient, both ends fall. So as x approaches positive or negative infinity, y approaches negative infinity. If it's odd, but it has a positive leading coefficient, it falls to the left and rises to the right. And you see here the end behavior. If it's odd with a negative, it's the opposite of that. It rises to the left and it falls to the right. Therefore, our end behavior is as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches negative infinity. So go ahead and see if you can answer the next one and press play when you're ready. So which of these graphs could have this leading coefficient? -3x to the fourth. It's even, so both ends do the same. It's negative, so they fall. B. All right, now let's take a look at root behavior. So when we look at root behavior, it depends on whether the factor associated with the root behavior repeats. We really call this multiplicity. I did not use this word yesterday, but it's multiplicity of the root. So whenever we have a factor that's raised to a power greater than 1, there is multiplicity at that root. So if we have a factor raised to an even power, any even power, then what's going to happen is it will be tangent at that, which means it bounces. If we have a factor raised to an odd power, it passes. Now, if there is multiplicity at that root, meaning more than 1, so an odd power greater than 1, then it doesn't just pass, it passes with inflection. So passes with an inflection at that point. So if we have, it only passes if it's no multiplicity. If there is multiplicity and it's odd, so 3, 5, 7, 9, odd multiplicity, then it passes with inflection. So if we look at this, this has to be an even root. So we would do This is -3, so it would become +3. And so it would have to be even. Here, it passes like a straight line. So this would be x minus 0 to the first. And here, it passes with inflection. So it would be x minus 4 to at least the third power. Now, this x minus 0, we would never write like that. We would just write it x. And generally, the monomials get put in front. So this problem could be written like this. This is the way to write this function with the least degree. Okay, so let's take a look at this. So we have these following polynomials that have roots -6 and 7. Use your knowledge of root behavior and end behavior to write an equation of least degree. So that means if it's odd multiplicity, we're going to go with 3 and not 7. Okay? All right, so hit pause, give these a try, and then check your answers. Okay, so this one has 2 roots. We have one here at -7. So for all of these, we're going to have an x plus 6 and an x minus 7. I'm going to go ahead and fill that in because those are our x-intercepts for every problem. And then what we just have to determine is multiplicity of the root, if there is multiplicity. And we also have to determine leading coefficient, positive or negative. Okay, so I'm getting all of them started. Now we just have to add in our powers for our factors and a negative or positive leading coefficient. Okay, this one passes at -6, so that would be a first degree, which I do not have to write. It is tangent here, so it would be squared. It falls to the left and rises to the right, so it would be a positive leading coefficient, which we really don't have to write. Let me change colors to make this very clear what we're doing here. We're doing the multiplicity, so this would be positive, this would be 2. Okay, now, same x-intercepts. This time, it is bouncing here, so this would be squared. And it is passing here, so this would be the first power. The end behavior is the same, so it's still positive. All right, we're passing, no inflection, so 1, 1. We don't even need the ones, okay? On this one, we are bouncing and bouncing, so tangent, tangent, rise, rise, so it's a positive leading coefficient. All right, so that's how you would write the equations. Now you're asked to sketch the graphs. So I want you to hit pause. I want you to try your best. Ask questions if you do not know what to do, and then press play when you're ready to check your answers. Okay, A. So for this one, we need an x-intercept at 3, at -1, and at 5. These are our zeros of the function, so we have an x-intercept at 3, 0, ignore that bell, at 5, 0, and at -1. The degree of this function is 4. It has a positive leading coefficient, so I start here, rise, rise. Okay, at -1, it's to the first power, pass through. At 3, it's to the second power, hit and bounce. At 5, it's to the first power, pass through. That's the process for all of these. So we'll come over here to -4. We'll put an x-intercept, one at 1 and one at 5. Okay, negative leading coefficient, degree is 1, 4, 6. Degree of the function is 6. Negative leading coefficient, degree of 6, fall, fall. Okay, we're going to pass at -4 because that is raised to the first. We're also going to pass at 1. But please note, there is odd multiplicity at this root. There's more than one. It's a multiple. When there's multiplicity, something different is happening. And what is happening here is we have the change in concavity of our graph, an inflection. So it makes a little squiggle in our graph. And then at 5, we have even multiplicity, so we will bounce. All right, this one is not in factored form. We take the GCF out. We factor what remains. And then we can clearly see our x-intercepts. We have one at 0, one at -2, and one at +1. The degree of this function is 5, or we can count here 5. And it's a positive leading coefficient, so it's going to fall to the left and rise to the right. Now, at -2, it just passes straight on through. At 0, it passes, but because of the odd multiplicity of the root, we pass with an inflection. And at +1, we pass straight through. So let me fix that to where it looks like I'm just passing through there. Okay. Now this one is partially factored. We can go ahead and finish this off here. And then we can look at the degree. So we've got 3, 4, 5. This has a degree of 5, positive leading coefficient. We're going to come in and plot our x-intercepts first. We've got one at -2. We've got one at -5. And our last one is at +1. Okay, so we're going to start over here at -5. We're going to think about the end behavior. It's got to fall to the left and rise to the right because it's positive and odd. We're going to pass right through at -5. We're also going to pass at -2, but because of the odd multiplicity of the root, we're going to pass with an inflection. It changes from its concavity there. And then at +1, we're just going to pass right through. All right. Now let's look at the last little part of our notes. Here they ask us to write an equation, and I'm going to put C right here instead of over here. So we'll just mark this out right here. There we go, on mine. All right, so we have a bounce right here, a pass right here, a pass right there. So we're going to go y equals, we're bouncing at 1. So it's x minus 1. We have to do the opposite, bouncing at 1. We're passing at 2. And we're passing through at 3. And at 2 and 3, when we passed, there was no inflection. So I have a 4th degree positive leading coefficient. That would get my end behavior correct. Okay, we're passing with inflection, passing, bouncing. So on this one, passing with inflection, when we do the opposite of the -2, it becomes +2. Passing with inflection has to at least be a 3rd power. Here we're just passing through. That's an x minus 0, which I just write as an x. And here we're bouncing. So at the x minus 1, which gives me the +1, it's going to be squared. Now, I'm going to have to go back in and give myself a little room because the end behavior falls. So this 6th degree function, 1, 4, 6, needs a negative leading coefficient. And the last one, this one is passing at 0 and it is bouncing at 1. So that bounce causes a tangency. That's an even multiplicity of the root, so I need at least a 2. And the end behavior is fall to the left, rise to the right. We're all good. All right, if you have any questions about any of this, please ask while you're in the classroom. Once you've finished, you can start your next page, which is your homework. So the front of page 2 is your homework. Please let me know if you have any questions.